Hi there, my name is Amber. I am a Senior DevOps Engineer with Liatrio, and I'm here to show you how we at Liatrio do automated governance. In this demo, we will be using a GitHub-hosted toolset, but we have implemented automated governance with other toolsets. So if you're using, let's say, GitLab, we have done that before. So the goal of automated governance is to reduce the risk of vulnerabilities introduced in a software development lifecycle. We want to oversee and ensure that certain events happened in the pipeline and were executed in an approved manner. Like we want to ensure that scans happen, testing happens, and PR approvals were obtained so that we can reduce the risk of introducing vulnerabilities through deploying unsafe software artifacts. So how do we avoid having to manually collect all of that evidence that certain events happened and how they happened? We can use attestations. And you can consider attestations like receipts of a pipeline event that can be created to provide proof that the event happened and provide evidence of how it happened and even where it originated from. This is how we can trust the artifacts. We can use these immutable attestations as proof of following an approved process. Through automation, we can create the very attestations for these events and guarantee they have not been forged or altered through capturing their provenance or their origin of the artifact. And then we can sign those attestations, and that way later on we can verify that each artifact was signed. That way, in the future, you can use them for gating. You can either check in the same build pipeline, or later on when you go to deploy, you can still verify that that software artifact was signed and has an attestation before having it get deployed. All of this is automated to stay out of the way of the developer, but enable governance over the software delivery lifecycle. So let's look at a tangible example of this. You are required to have an SBOM for a software artifact. And so you're looking at your pipeline, and can you answer these questions just by looking at your pipeline of, was an SBOM created? Or how do you know that that SBOM wasn't spoofed or altered even after creation? And then in order to collect evidence for these questions, do you have to do that manually, clicking through the pipeline, downloading things? When you implement automated governance, you should be able to answer all of these questions without having to manually go through and collect that evidence by hand. You'll have the evidence built in. So what this will actually end up looking like in a pipeline is you'll have a developer and they'll have code to push, and at the end of the pipeline they'll have that release. They'll be putting out a new version of their code. So you'll see some standard jobs like they got to do a build image, they need to run unit tests, or they're required to do a security scan. But with automated governance implemented, we get receipts for each of those jobs. So you see those little attestation receipts in there. And inside of those attestations, you have all of this evidence of how that job was ran. What are the origins of that job? And we can feed those receipts through policies. And when we evaluate that policy, that can give us a pass or a fail. And that's one of the opportunities for us to give feedback to the developer of, you're missing certain events in your pipeline, or you can go and evaluate this later on to determine readiness for deployment. So you can gate now, or you could even gate later on, depending on your environment restrictions. And the policies are meant to be maintained by a different group of people, and they're helping establish what the standards for these pipelines should look like. So that gives us our separation of who can edit what. So the developers cannot alter these policies within this pipeline. But since this policies will be pipeline as code, the developers could go look at them and understand right away what they're missing. Now, with using GitHub, you'll get some stuff out of the box. We'll get to have an attestation created for the provenance of your build. That comes out of the box. You'll also be able to get the SBOM attestation created out of the box using the GitHub attest actions. And then we can also create custom attestations for other pipeline events and metadata. Like if there's a specific scan tool you're required to use, we've also created custom attestations for events like those. And the policies provide a way to write rules for requiring such events in the attestation. So it provides those gating opportunities based on the pass-fail nature of these policies. And these policies, again, can be seen and contributed and read in by developers, so it's not hidden through any obscurity. They can go find the code because it's in a repo and read through it, and they can match it to the feedback they're getting in their own pipeline. Now, how do we know that our implementation is any good? We follow SALSA, and SALSA is a set of incrementally adoptable security guidelines established by industry consensus. And our implementation was designed with SALSA in mind each step of the way. And so we used it as a guiding framework for building software with integrity. Now, there are levels to how much you can adhere to the guidelines of SALSA. The highest level you can get is a level 3, and by reaching level 3, you had to have adhered to all of the practices outlined by the previous levels and the third. And just creating a attestation does not accomplish a SALSA level 3 on its own. You have to be intentional about how you put together your build process. So we've implemented a SALSA solution using the GitHub attestation feature that meets that SALSA level 3 by adhering to those practices. So that means no tampering during the build process, no tampering after the build process, and then there's some basic traceability and documentation. But that really means we utilized reusable workflows and composite actions, if you're familiar with GitHub. But essentially, we had to make sure that developers could not tamper with the results of these events in a pipeline. So how can we create these attestations anyways? We use a tool called SigStore. And SigStore is the standard for automated governance. It relies on using an OpenID Connect token from GitHub to sign the items that are built and created in our software pipeline, here in GitHub specifically, whereby the attestation signatures and other data is all stored in an immutable store. It's called Recore. It's just another tool in the SigStore stack. And that Recore instance, the store of evidence, is accessible for audits later on or for later trying to gate, because we'll use that to check and verify that these artifacts have been signed and have the attestations. So here's just a visual of the full stack of what SigStore is. You'll have that Recore, and you'll also have full CO for signing. But with GitHub, they're hosting these on our behalf, so we get to focus on just developing code. So that's why we chose it for the demo. So we don't have to host any of these ourselves. We can just use the GitHub-hosted version of these and worry about the pipeline aspect. All right, so let's see what this actually looks like in action. We have just a demo app. It's a little Hello World app meaning to represent a developer's point of view. And we wanted, as a developer team, we wanted to implement the automated workflow, or the automated governance workflow. And so we have a YAML that establishes our workflow. What we get to do is we basically reuse a standard automated governance workflow that outlines all of the rest of the jobs that were required to have to make the attestations happen. And that way all we have to worry about is the actual build. So we have our Docker file and we're defining the build for our Docker file. So we get to determine how it gets built, but the rest of it, we don't have to worry about it. And our resulting pipeline gets to look like this. So the one job that we influenced as the developer was the build, and the rest, the things where it builds the attestations and requires the SBOMs, we didn't have to write that in. We got to pull it in for free from our team that manages, the automated governance workflow. For all intents and purposes, that's still us right now, but this is for a demo purpose. Since we have these jobs that create these attestations for the build, and we have some metadata we're also attesting to, and then we also have that SBOM, we get all the evidence that these things happened, and we get to reuse all of that evidence later on, but we can actually see them in the UI. We get attestations created for the build. We get an attestation created for some extra metadata. And then here's our SBOM attestation. So here's how we're already able to prove, yeah, we had an SBOM created. And what some extra things happened is we get those attached as artifacts at the very end too. So once we've created those attestations, we verify that those attestations are correct. And with the verification passing, we get to reuse the attestations for our policy evaluation. We use a tool called OPA, and we use Rego to write the policies, and we use OPA, it's a command line utility, to run the policies. So we feed in our attestations into an OPA CLI command to evaluate, and it'll run and check that all of our policies are being met through the evidence supplied in the attestations. And we do output the run of that OPA command, and we throw it into a JSON. And so for this purpose, we get to see, hey, my results passed, and if they failed, we output why they failed, so the developer gets feedback right away if they're missing a particular job, or if it didn't pass because there were vulnerabilities identified in one of the scans. And then if that all passes, we should get to proceed with releasing. Now, in between running OPA and releasing, this does present an opportunity to gate right here if you wanted to, or even warn if there is a failure in the policy. So this could be our first step in alerting or giving feedback to the developers that they need to go and change something about their workflow to make sure that it is meeting standards. And then we can use the attestations at a later point in time to go reassess if this artifact is ready to be deployed, because these attestations do get stored in GitHub. So we can access them at a later point in time, like at deployment, to see if an image is good enough. And then we'll get these images that you can match the SHAs to the attestations. So this is kind of what the attestations get to look like, and we'll see that they'll match the SHAs for the image digest. So that is the basics of how we have implemented some automated governance from the CI side. Thanks.